Hey everyone, I am absolutely thrilled to have you here today. In this explainer, we're doing something that is honestly incredibly fascinating. We aren't just looking at a company's product today. We're actually popping open the hood to examine the literal architectural blueprint of how one of the world's largest professional networks builds its tech. We're going to use LinkedIn's own engineering blog taxonomy as our map. By digging into how they categorize their innovations, their data, and their culture, we can essentially reverse engineer the engineering brain of a massive global tech giant. It's basically a masterclass in organizing complex systems, and I can't wait to get into it. Right at the very top of their blog, you'll see this core tagline. Now, you might be thinking, okay, sounds like a nice piece of marketing, but when you're looking at a platform operating at this kind of astronomical scale, this is actually a structural mandate. The technology ecosystem here isn't just designed to keep the lights on and the servers running. No, it is explicitly built to evolve, to scale, and to act as a real catalyst. Every single line of code, every data stream, and every new AI agent we're going to look at today is engineered to spark that innovation and ignite growth, both for the company itself and for its hundreds of millions of members. Okay, so here is our game plan for today. First, we'll look at the blueprint of a platform. Second, data and core infrastructure. Third, we'll dive into scaling AI innovations. And finally, engineering culture and talent. Let's dive right in. Starting off with Section 1, Blueprint of a Platform, Mapping the Engineering Brain. When you're looking at an engineering org of this magnitude, leadership has to somehow divide the cognitive load and the structural responsibility across literally thousands of engineers. Notice how they manage that vast complexity. They don't just have one generic trust and safety bucket. They explicitly carve out fairness, verification, and security as completely distinct, massive focus areas. Or take product design. They have dedicated engineering tracks for accessibility, right alongside things like messaging and the feed. And within their AI division, responsible AI sits right there next to generative AI and machine learning. The big takeaway here is that at this scale, ethics, safety, and accessibility are absolutely not afterthoughts or simple compliance checklists. They're foundational engineering pillars that demand their own dedicated teams. Let's move to Section 2, Data and Core Infrastructure, the foundational layer. Obviously, none of those high-level product features mean a thing without a rock-solid foundation. Their infrastructure focus is entirely centered on handling, well, just astronomical scale. We're talking deep investments in distributed systems, cloud computing, and automation. But I really want to draw your attention to a very specific recent innovation they've talked about, Northgard and Xinfra. These are their custom solutions for scalable log storage. Now, log storage, which is essentially the background diary of everything the software is doing, might not sound super glamorous. But when you have billions of digital events happening every single day, storing, indexing, and actually retrieving those logs without completely crashing the system, that is a monumental engineering feat. Innovations like Northgard and Xinfra are the unsung heroes keeping the whole platform reliable for the engineers running it. Now, what's really wild is how they conceptualize data. They don't just dump user profiles into some massive flat database. They organize the world's professional data into interconnected graphs. You've got the economic graph, the skills graph, the knowledge graph. Every member, every job posting, every skill is a node, and the relationships between them are mapped through massive data streams. And they're constantly refining this whole ecosystem using super rigorous A/B testing and experimentation pipelines. This graph-based architecture is exactly what allows them to understand not just who you are, but how you fit into the entire global economy. It's like a giant puzzle coming together in real time. So that brings us to the multi-billion-dollar question. You've got all this incredibly structured data in these massive graphs, right? And you have the infrastructure to stream it all in real time. What exactly happens when you take that foundational layer and you crash it head-on into cutting-edge artificial intelligence? Which brings us to Section 3, Scaling AI Innovations, Redefining Search and Quality. Historically, search on platforms like this relied heavily on traditional keyword matching and ranking algorithms. You type a word, it finds the word. But a recent breakthrough detailed by engineer Fedor Borysiuk outlines a total shift to a scalable LLM, or large language model-based architecture. What this means for you and me is that the system now actually understands intent and context, not just text strings. It powers a smarter, faster, and exponentially more personalized experience. Think of it like the difference between asking a librarian to find a book with a specific word in the title versus sitting down with a brilliant career advisor to find the exact opportunity that matches your unique career trajectory. It is a total game changer. And this kind of innovation is spreading like wildfire across the entire platform. Just look at these recent updates. Asakusuma's team is completely reimagining software quality by deploying AI-driven QA agents for autonomous testing. Just think about that for a second. AI is testing the code written by humans, which dramatically speeds up the development cycle. Then you've got Nikita Siltsup's work on semantic search for AI agents at scale, specifically retrieving and ranking data for their hiring assistant. And behind the scenes, they're optimizing the training efficiency of generative recommenders, so these massive models run faster and cheaper. This isn't just them slapping a chatbot onto a website, they are fundamentally rewiring the platform with AI at every single level. And all of this underlying tech really serves one major business goal: velocity. Engineer Tanmay Khemka recently shared how they're accelerating their go-to-market speed using something called the Product Configuration Center. Basically, by platformizing their tools, which means creating reusable, shared foundational tech, they remove massive bottlenecks. They allow product teams to configure, test, and deploy new features incredibly fast without having to rewrite the foundational code every single time. The whole shebang is about giving developers the exact leverage they need to build the future faster. Finally, let's wrap up with Section 4, Engineering Culture and Talent, the Human Element. At the end of the day, no matter how automated the testing gets or how incredibly smart the language models become, it is the human element that imagines, builds, and maintains these complex systems. And a huge part of a strong engineering culture comes down to structured, technical hiring. Actually, here's a fascinating pattern engineering leaders look at. Why does one engineering role close in, say, 3 weeks, while another identical role just sits open for 60+ days? It's rarely about recruiter effort. It usually comes down to role clarity, market alignment, and decision speed. Roles that close fast have a really focused brief and realistic expectations. When requirements constantly shift or there are too many must-haves, even the strongest candidates move on. So the best teams don't just measure time to fill, they study why roles stall to optimize the process. And that focus on efficiency extends directly into how they treat their existing talent. They prioritize developer experience and productivity, ensuring engineers have frictionless tools. And they're heavily invested in the broader community too. Take the recent announcement by Natesh Pillai regarding the LinkedIn Cornell 2024 grants. By fostering academic partnerships and supporting leadership development, they're actively cultivating the next generation of tech talent. They know that a world-class platform absolutely requires a world-class culture. We have covered an incredible amount of ground today. We mapped the platform, we explored those massive interconnected data graphs, and we saw how large language models are completely rewriting the rules of search and autonomous development. But I really want to leave you with this final provocative thought. If this is the architectural blueprint of LinkedIn engineering today, as AI agents become even more capable and generative models become even more deeply integrated, how is this very blueprint going to evolve over the next 5 years? Will we even recognize the taxonomy of a tech giant by the end of the decade? Thank you so much for joining me on this explainer today. Keep exploring, and I will see you next time.